Hey guys, welcome to my channel. In the previous videos, we have completed many topics. Let's discuss what all we have completed. We have started NMR spectroscopy. We have completed the quantum number, the role, principal instrumentation, solvents, relaxation process, and various solvents, various signals of NMR compounds. And we have also completed the chemical shift factors influencing chemical spin and spin coupling, spin splitting and coupling constant is also completed. In this video we will only study nuclear magnetic double resonance. Nuclear magnetic double resonance is an very important topic, so we will understand this topic very clearly, and in the next video we will complete the NMR spectroscopy and we'll start mass spectroscopy. Okay guys, hope you're doing well, and once again welcome guys to my channel. Here I'm going to teach pharmacy syllabus one by one. If you're watching, please subscribe my channel. It's really helpful for me to get motivated and to make more videos, more informative videos. Okay, let us start the video guys. Okay, nuclear magnetic double resonance. What do you understand by nuclear magnetic double resonance? Here there is an nucleus, there is a magnet, and the process is taking twice double, and there is a process called resonance, and it is also called as decoupling. Okay, normally the sample, let's continue with the definition. Normally the sample is subjected to a single radio frequency field. If second radio frequency is applied in a specific manner, then a series of techniques collectively known as nuclear magnetic double resonance. See, normally we use only one single radio frequency field. Okay, single radio frequency field. If we use second radio frequency and series of techniques occurs, which is collectively known as nuclear magnetic double resonance. Okay, I hope you are understanding. Here we are using secondary radio frequency, okay, field, so that it is called as nuclear magnetic double resonance. We will go through, it's very simple topic. I'll explain, I'll make sure that you are getting understanding, you are understanding. Okay, for example, take a sample AX system. Takes an like, just take an example which is the AX system. The X nucleus is irradiated with secondary radio frequency signal of frequency Vx. Okay, here nucleus is irradiated with the secondary radio frequency signal, which is Vx, equal to the precisional frequency of X. Okay, it is telling that the secondary radio frequency is equals to the first radio frequency, then the X nuclei will undergo rapid changes to spin split. Okay, see here what is happening, right? First we will apply the first radio frequency, and then we will give the second radio frequency to the nucleus itself, to the same nucleus itself, and the nucleus undergoes rapid changes in the spin state. We'll read in detail. This is the process. Okay, see, nuclear magnetic double resonance is a specialized technique in NMR spectroscopy that significantly simplifies complex NMR spectrum, making it easier to determine nuclear molecular structure. Okay, first understand this line. See, spin splitting or coupling, what we studied in the previous class, gives an unwanted spectrum. Okay, unwanted spectrum we studied, right? It gives an unwanted spectrum by interacting with a neighboring nucleus. The unwanted spectrum is reduced by decoupling. Coupling means increase, decoupling means decreasing in the, see, in the complex spectrum. See, significantly simplifies complex NMR spectrum. makes it easier to determine molecular structure. Okay, I hope you are understanding. It achieves this by decoupling the spin-spin interaction between different types of nucleus. In coupling, what was happening? Spin-spin interaction was happening, which was forming an complex spectrum. Okay, spin-spin coupling forms complex spectrum, and this is called proton coupled. The problem is spin-spin coupling. Because of spin-spin coupling, there was a complex spectrum, because here in this spectrum we can't identify which of the compound we are getting. But the solution is decoupling. Decoupling, what it does, it prevents the spin-spin interaction between different types of nucleus. By preventing this, we will get an simpler NMR spectrum than the complex NMR spectrum. Here see, the spikes are very clear, they are not diverting. Okay, then this is very simpler, and by the decoupling we will get a simpler NMR spectrum. That is nuclear magnetic double resonance is called decoupling. Okay, see, a nuclear magnetic double resonance addresses this by appealing to uh, two radio frequency signals simultaneously during NMR experiment. See here what is happening, right? We studied in the principle that we are in this experiment we are using two radio frequencies. Okay, first one and second one. See, first observing frequency V1 and decoupling frequency V2. Observing frequency is the first radio frequency, decoupling frequency is the second radio frequency. Decoupling radio frequency is what reduces the complex spectrum. Okay, it is converting the complex spectrum into a normal spectrum by decoupling frequency. Okay, we'll just understand what is the process of it. When the decoupling frequency V2 is continuously applied to a coupled nucleus B, it causes the spin of nucleus B to flip rapidly between its energy states. Here what is happening, right? Here the decoupling frequency V2 is continuously applied to a coupled nucleus B. It causes spin of the nucleus B to flip rapidly between the energy states. Here when the frequency is applied to the nucleus B, it causes flipping, okay, rapid flipping between the energy states. See here, the rapid splitting effectively averages out the magnetic influence of nucleus B on the observed nucleus A. We studied that nucleus A and nucleus B through spin-spin splitting causes the complex spectrum. But here due to the decoupling, it averages out the influence of the electromagnetic radiation of nuclear B on A. It averages out and this decreases the complexation of the spectrum. See, this rapidly flipping effectively averages out the magnetic influence of nucleus B on the observed nucleus A. As a result, nucleus A no longer seeks the individual spin state of nucleus B, and spin-spin coupling between A and B is eliminated. See, I have said right. Here what is happening, the spin-spin coupling is eliminated by using of decoupling frequency. That is the double resonance nuclear magnetic double resonance concept. And what is the result of it? The multilate signal for nucleus A collapses into a smaller signal. Often a singlet makes the spectrum much cleaner and easier to interpret. Okay, I think so you have understood. The concept behind it is that, see, I'll just show you the diagram here. The concept behind double resonance, why we use the double nuclear magnetic double resonance, because due to spin-spin coupling, it is a problem which gives a complex spectrum. Okay, complex spectrum. complex spectrum can be also be analyzed, but it is very difficult and it takes lot of time. And the solution is decoupling or nuclear magnetic double resonance. By using the nuclear magnetic double resonance, the spectrum or the spin coupling is completely eliminated. Okay, and we get a spectrum which is not complicated, okay, which is not complex. This is the concept behind nuclear magnetic double resonance. I hope you understood it. For today we will stop the lecture for here. In next video we will complete the full chapter. Okay, thank you guys for watching. See you in the next video. Take care. Bye.